Hello and welcome to a new video tutorial where I'm going to be showing you how to create a TCP server using the C language. Now I have only on the channel one C programming language video tutorial. It's mostly an introduction to the C programming language. For me, the best way to learn a language is by doing. So you'll learn by doing. And by the way, this is very valid if you want to learn any other language, not only programming, but a human language. So it's okay to sit down and learn the alphabets, the grammar, the rules, everything that it's actually governing this language. But I believe that a better solution to learn the language is by practicing it, even if you'll do some mistakes, or even if you will say something that you don't fully understand at first, but by time you will get the idea. So this is my philosophy, and I'm going to apply the same thing here on the channel. And if you have noticed, I've never explained or never had a crash course on a language, except maybe for Rust and Kotlin, and that's it. But I have crash courses on database systems or frameworks, that's fine. But for a language, I don't know. That's the way I think, guys. So yeah, as I said, today I'm going to show you how to create a TCP server in the C language. So as you may know, the C is the mother of all languages like C++, C#, Java, JavaScript, all of that. C is a very fast programming language, compiling very quickly to machine code in no time. And as I said, I have a quick introduction on the C language if you want to check this out. And I'm going to be working here with WSL2. This is Windows subsystem for Linux. It's very easy to install, by the way. And the reason why is that I have the GCC or the GNU compiler for the C language installed here on my Linux machine. So this is the main reason why I'm going to use Linux for this tutorial. So I'm going to create a folder. I'm going to go to Home first, and then this folder, I'm going to call it C-TCP. Just make this a little bit darker. All right, and yeah, so let's cd to that. And let's create that file. I'm gonna call it server.c. So this is the file basically, and I'm using here NewVim. So the first thing we want to import. So if you're coming from Python programming language background, I'm going to try to make it closer to Python. I mean the equivalent to what we're doing in C in Python, if that's okay with you. So first of all, here I want to do the include directive. So in C programming language, there are the include directives. These mainly are used to include some header files, which are similar in concept to the import statement in Python and JavaScript, by the way. So the way to do that is to start this by hash or pound key, and you will do include, right? That's the header. And inside I want standard input output dot h. Okay, this is the first header. Next, I want to include the standard library. So this is the standard library. So first here is the input output and the standard library. Next, we want to import or include this header, right? Which is string.h. This is for string manipulation. Also, I want to include the POSIX. This is a operating system API library, and it's called unistandard.h. Finally, I want to include ARPA. /inet.h, and this is to include the internet address manipulation library. All right, these are the 5 libraries that we need to include in our program. Next, I want the define keyword or the define directive. So let me just put here a comment, and I will say include directive is equivalent to import statement in Python and JavaScript. Next, I want the define directive. And this is quite a new concept for you if you're coming only from Python or JavaScript background. So you can actually create some macros that can be used in your program later. So let's say, for example, that we want to create a port macro to be 8080, the port 8080 to use it later. The way to do that is to type define, and that's the macro. But the macro here is not going to be just macro like that. We will delete that now by typing port and directly the number of the port. Also, I want a buffer size, which is 1024. So define buffer underscore size, and that's 1024. And buffer, by the way, is memory that you want to store in when you want to transmit it from one location to another location. By the way, you can create macros normally. So for example, if you want to create a macro that calculates the square of a number, you can do that here. You can say square like that, and that takes x, and what it does, it multiplies x by x, right? That's going to be exactly the same thing in Python. If you will do the lambda function, for example, you will say here square, and here lambda x, and the column, the separator, x multiplied by x. This is in Python. Now I want to create my program's entry point. In C language, you need to have a main entry point for your program to work. It's like you would do in Python def main. This is your main function, right? You can type some code here, print hello world, name equal to whatever, and then you will have your if name code block. It's something like that, right? I don't know why the indentation, yeah, like this. This is what you would do in Python, right? So this is the closest idea to what we have here in C language. So here we have the program's entry point, and we want to do int main open curly brace, and inside here we need to have our code. So the first thing, I want to declare integer variables for the socket file descriptor. So to do that, I need to specify that this is going to be an integer, and I'm going to give the name of my variables. So the first one will be server underscore fd, this file descriptor, and also I want a new socket. Also I want a struct, and a struct, by the way, is very close to a class in Python. So this is a structure to mainly hold the socket address information. So that's going to be the sock address in. You can see here that this structure describing an internet socket address. Next, I want to declare a variable, an integer variable for the socket options. And I'm gonna call that opt, and I'm going to make it 1. We have only one option for one socket. Next, I want to declare a variable to specify the size of the address structure. So you see this address here? This is, I need to feed this variable inside a method called sizeOf, and then after I'm going to store that in another variable or integer variable called adderlen. I'm going to call it adderlen. So sizeOf, and the expression that we have for the variable is the address. Also, I want to create buffer size. So we have defined here the buffer size for 1024, and buffer here is going to take the buffer size macro above. So this is an array buffer, and we have initialized it with zeros. And that's not all, because I want to create a socket file descriptor now. I will need to check out if the server file descriptor is equal to the socket. So inside here, this domain is going to be the AF, or the address family inet. And I've explained this. You know, all of the socket programming in different programming languages basically are the same, but the syntax is different. So I've explained this in Rust, I've explained this in Python, and in C, it's no different. So what I want here is the AF underscore inet, and the type and protocol. The type, I want the sock or the sock stream. That's the type, and the protocol is 0. So here we are creating a new socket of type, right? So this is basically the socket method, okay? We create a new socket of type in domain. In our case, the AFINet and the sock stream. All of that, if it's equal to 0, we're going to return a failure message. So basically what we have done here is that we have checked out if the socket creation fails, we're going to print an error message and then we're going to exit. So let me just add a comment, create a socket file descriptor, and then after I'm going to print an error message saying that, let's say for instance, socket failed. And then we're going to quit or exit failure. Next, what I want to do is I want to set the socket options. So I want to check out if the socket option fail. Also, I want to print an error message and exit. So the way to do that is I'm going to say if set sock opt, and then here I want to have the first argument as the server descriptor. Also, I want the level that should be an integer, which is sol socket. The third argument is the reuse address. The fourth argument, the socket reuse address or port. So I'm going to do that this way. The sockets the socket reuse port. So either of those, this or that. And also opt, and finally the size of the options. So if all of that is true, what I'm going to do, again, I'm going to print an error saying that so if all of that is true, I'm going again to print an error, and we're going to say set sock opt. And also we're going to exit. The next thing probably that I want to do is to set up the server address. Set up address, and let's just do address.syn family AFINet. So this AFINet, by the way, that's the Internet Protocol 4. And again, I've explained all of that, so I will assume that you understand socket programming, by the way, in this video. So here I'm setting the address family to AFINet, right? That's the Internet Protocol version 4, not 6. Also, I want to set the IP address to in address any, right? So that's going basically to accept the connections on any available interface. So the way to do that, again, I'm going to say address.syn underscore address or address.s underscore address, and that's equal to in address any, right? So this way we are accepting connections from any available interface that exists here. Next, I want to set the port number in network byte order. So that's very easy to do. Again, I'm going to take the address and I'm going to get the syn port, right? And that's going to be equal to h tones, right? The h tones here is going to accept the port, which is 8080. And after we have done that, we want to bind the socket to the specified address and port. So I'm going to check out if method called bind, and bind takes different arguments. The first is the file descriptor. Next, I want a tuple, and that tuple is going to have the struct sock or socket address with this asterisk. That means any socket address concatenated with the address. And also I need the size of the address, and all that if less than 0. So this actually means if binding the socket fails, we're going again to print an error message and exit. So again, print error, we're going to say bind fails, and we're going to exit failure. Now I want to start listening for incoming connections. How to do that? I'm going to check out if, and a method called listen, and listen takes two different arguments. The first one is the file descriptor, our server file descriptor, and the second argument is going to be an integer, an n number. I'm going to give it 3, and if this is less than 0, so if listening to the incoming connection fails, we're going to print an error message again, print error. We're going to say listening failed or fails. We're going to exit. And if all went well, we're going to print to the console saying that server listening on port, and whatever the port is, our port macro here above 8080. Right? That's the way to do it. Now I want to accept incoming connections. How to do that? Well, it's very simple and very easy. I want to check out if new socket equal to accept, then accept takes again the server file descriptor as first parameter, then the address of the struct, so struct sock address, not in, just sock address also concatenated with the address. Also, I want the length of the socket, sock or socklen underscore t asterisk, and the address length. We're going to again print an error message, exit failure. But in case that everything went okay and the connection was accepted, we're going to print to the console connection accepted, and we'll move on a new line. And before we close the connection, there are 3 small steps that we need to do. The first is reading data from the client and print it. So we're going basically to declare a signed size type variable for the number of bytes read. How to do that? By saying size t val read. That's the name of the type variable. And then I will have a while loop checking if that val read is equal to a method called read that will take that server file descriptor as the first, or no, I think it should take the new socket. It should take the new socket, right? Because we want to say, because we want to check out while there is data to be read. So we will need that new socket, not the server file descriptor. So I believe that's going to be the new socket. The new socket. The next is going to be the buffer. And the third variable is the size t. So that's the buffer size. So buffer size. And if all that is greater than 0, I'm going to print client and whatever the client is. Next is buffer. And then finally, I want to clear the buffer. To clear the buffer, I'm going to use a method called memset that takes 3 different arguments. The first is, as you can see, void with an asterisk, and that's going to be the buffer. And a number, we can leave it to 0, and unassigned long, that should be long. So that's going to be the size of the buffer, right? Size of the buffer, which essentially is going to be long. Long data type is used basically to declare variables that can store integer values, but with a larger range than the regular integer data type. So yeah, I think that's all. And yeah, I need to close the socket using a method called close, and that's our file, server file. And then I'm going to return 0. This means we have a successful execution. So now let's go ahead and compile our program and see if everything is going to be working as expected or if it will have some bugs. So the way to do that here is I'm going to use the GCC, which is the GNU compiler for the C language. And then the name of the file, server.c. And then I want it to be an output file, so -o. And then the name of the executable that I wanted. Everything went okay and compiled. Let's check what we have in our folder. We have server executable file in green and our server.c. So let's go ahead now and run our executable. And we are listening on port 8080. The server is working perfectly. And let's go ahead and go to the localhost port 8080, and there we go. Connection accepted with the client, the name of the browser, right, the platform, everything. Alright guys, so I think that's it for this tutorial. Thank you so much for watching. If you have any questions, if anything was not clear to you, please make sure to drop your questions in the comment section below. And yeah, I will see you in the next video.